This presentation is on the shielding effect and how it causes things to occur in periodic trends. Alright, so if you look at the graphic up here on the left of the screen, you can see that somebody has drawn a little performer, if you will. Looks like he's playing the guitar, and there's a drummer in the background, and they have speakers. And so then you have, it looked like it might be a concert. So they're standing up on a stage, and then you have all of your people are watching the music, the concert, and they can see if they're in the first row, maybe in the second row they can see, but as you get to the third row and the fourth row, they are blocked. You are not able to see nearly as well because of the people in front of them. And this is an example of the shielding effect. I also like to say the shielding effect is like when you are talking rudely to somebody up close. They can see you, and they're going to respond right to your face and right away. Maybe they're going to reach out and touch you. But if you are across the house, upstairs, through other different rooms, and you're smarting off, whoever you're smarting off to may not see you, may not hear you. You may be able to get away with it because you're shielded by the walls in the distance. So that is like the shielding effect. So here is the real science version of the shielding effect. You can see in the bottom right. It says the electrons between the nucleus and the valence electrons repel each other, making the atom change. It could make it larger. We're not necessarily looking at a specific trend. But the nucleus has a pull, as we saw in the nuclear charge, and this nucleus is pulling on the outer electrons. Well, it can only pull on the outer electrons when it has a direct path. It's going to get pulled a little bit less whenever there's other things blocking it. You also have, these electrons are all negative, so this one's negative as well, and so is this one, and over here's a negative electron, and our nucleus is positive essentially. So these electrons also have repulsion factors between each other. So the electrons are trying to be attracted to the nucleus, but they're blocked by these other inner electrons that are in the shell between, blocking the power of the nucleus. So the electrons only experience an attraction. The outer electrons only experience an attraction based on either how close they are or what all is in between them. So the shielding effect is basically things will be diminished based on how far away from the nucleus they are, or based on how many electrons are between the nucleus and this outer energy level.